Here, I want to give you an idea of how I can design my network efficiently and effectively. So I have different devices. As I told you, I have layer 1 devices, I have layer 2 and layer 3 devices. And as I told you, repeaters and hubs are not good devices to be used in my network, so I'm not going to use them. As I told you, I prefer to go and use switches, and they are better than bridges, and of course the investment is going to be worth over time. So let me start with switches. Assuming that my network is in one floor of a building. I do not have multiple floors, I just have one floor building. And I have different devices in this building, and the cabling is already done. So what I need to do is put a switch in between. And if I have multiple devices, of course, I will go for multiple switches. But assuming that I have about, for example, 20 devices here, and this switch has about 24 ports. So every device can be connected to this switch, and they can connect to each other as well. So that remains, that gives me a lot of possibilities. So, for example, these are the different ports that are connected to this switch, and devices are going to be connected to this devices. This is my first, second, third, fourth, fifth, a lot of other devices. And these devices, of course, can be of multiple types. For example, these are laptops, these are computers, these are printers, and different devices can be connected to my switch. So I have connected every device to the switch, and everything is going to be okay. So what if I have a lot of devices and my switch does not have so many ports? That's okay. I will go and create, buy another switch and put it here and connect these ports to other devices as well. For example, these are the ports that are connected to different devices. And of course, I need some ports of these switches to connect to each other. And I'm going to talk about these later. These ports are going to be, high-speed ports. And you can see some of the switches have 2 or more ports that are, high speed, and you can, connect these switches to each other using those high speed connections. And why would I go for high speed connections? Because I have a lot of devices here and a lot of devices here, and they are going to talk each other. So only one port is not going to be enough. So I am going to use gigabit Ethernet ports, 1 or even 2 of them, to connect these two switches to each other. So this is okay for this building. What if I have multiple buildings? If I have multiple buildings, I will go and put a switch in each floor. Or, if I have multiple floors in my building, So let me copy this part of my network. And that's going to, select this part of my network. Okay. Copy and paste it. This is my another floor, and I can have multiple floors in my building. What I need to do is put a switch in between. Of course, I can go and again connect these two switches using a cable like this. And this cable is a high-speed cable that is connected to high-speed ports on my switches. But I prefer to do something else. I prefer to use another switch in between, here for example, and connect these switches to this switch, like this. And this gives me a better option to add multiple floors and manage those floors, and that's going to be much better. So this is the type of design that I'm going to have in multiple floors. And what if I want to connect to other portions of my network or internet? What I need to do is to put a router here. And the best place to put a router is to put it here, where the central switch is there. So it is connected to this router, and it is going to be connected, for example, to internet or other portions of my network. So this is going to be this kind of design. So what if I have a lot of buildings, a lot of, devices, and of course I'm going to have multiple switches. For example, more than 20 switches in my network. I need to go for a type of design that is called a three-layer design. A three-layer design, let me write it like this. It is a Cisco recommended design, and of course you can combine two of these layers into one and have what is called a collapsed core. But we have a core here, we have a distribution, forgive me for my bad handwriting, and we have access layer. And if I want to draw it, that's going to be like this. We have layer 2 switches like this, multiple of them, in different buildings, different floors, but what is common between them? They are all connected to devices, end devices, such as laptops, printers, different file servers, for example, access points. They can be access points as well, because they can handle wireless devices. And this is going to be my access layer. So I can have a lot of switches in my access layer. All of them are layer 2 devices. They are not going to be layer 3. They are going to be layer 2 devices, and this is a very recommended by Cisco. And we have another layer, and this can be between buildings. It can be in one of buildings. I don't care about where they are right now, but they have, for example, 2 of them, and you can see that these switches do not connect to each other. They connect to these switches. And if I want to, go for redundancy, each switch connect to every, distribution switch. Each access switch is connected to every other, distribution switch like this. So you can see that I am writing this. And distribution switches can be layer 3 or can be layer 2. But mostly, if you want to have routing using switches, you are going to put those switches here. They are layer 3 switches mostly. So this is called distribution layer. And of course, I have a core layer here. And core layer consists of 2 or more switches that are so fast. And they are layer 2 as well. They are not going to be layer 3. They are layer 2. But some of network admins prefer to put layer 3 switches here. That's okay, but mostly it is recommended that you put layer 2 switches here. So we have kind of a design that is called collapsed core. In collapsed core, you do not create a core section. Actually, the distribution section is working as a core section too. So this is the 3 layer, but as I told you, you can combine these two in one layer, in one layer, and instead of having, for example, 2 more switches here, you can just use these 2, and that's going to be your collapsed core. Actually, distribution and core collapse into 1 layer. So you can see that using this design, you can have a lot of devices connected to your switches. They can connect to a higher level switch like this, the distribution switch, or core and distribution at the same time. And you can, of course, do a kind of routing that is called inter-VLAN routing. We are going to talk about this later. And that's the type of design that we should go for. And of course, if you want to have routing, you can connect routers to core section as well. And of course, if you want to have high-end server, if you want to have servers that need to feed data to your network, you again go and connect those servers to core. And this is what we call it a very nice and a very, Um, nice design. That's it. That's it. Nice design.